Oh, hey, welcome back to our series on Facebook LeetCode interview questions. Sorry, I took a break last week. I had a couple of big interviews I had to do, and I'm going to hear the results in about 12 hours, so that'll be fun. Um, Pretty awesome. And then, yeah, so we're going to go ahead and continue with our series. Let's go ahead and jump into this. So we're going to do number 162, find the peak element. Peak element is an element that is strictly greater than its neighbors. Given a zero-indexed integer array nums, find a peak element and return its index. If the array contains multiple peaks, return the index to any of the peaks. You may imagine that nums at -1 is equal to nums at n, which is equal to nums at is equal to negative infinity. So the numbers outside and to the right, represented here, and the number outside to the left of the array is the smallest number in the entire universe that you can come up with. So ideally saying that position 0 or position at length -1 automatically have an element there greater than. So interesting to look at. In other words, an element is always considered to be strictly greater than the neighbor than outside array. Okay, we just covered that. You must write an algorithm runs an O log n. When you see this here, O log n, that's a big old hint about what kind of method you should take, and that method will be a binary search. So in a normal binary search, we're given a sorted array, and we are looking for a target value based on whether or not it is greater than or equal to, or greater than or less than that number, the midpoint. And we just go through that. So basically what this does is it's a different set of rules. It's sort of sorted in the way, I'll give you a little show and tell right now. So let's go ahead and look at this. So we have 1, 2, 3, 2, 1. So you can see that it is sort of sorted. So there is a method to the madness. We will have this number here. So ideally, what our idea would be, we have our midpoint, we'll have our start pointer, and then we have our end pointer. So instead of comparing our midpointer to our target, moving left or right based on that, we're going to be comparing it to its neighbors. So what we're going to do first is take a look at our midpoint and then compare it to this 2. We're looking for a peak. So if this 2 is less than this 3, we know that our peak is not on our right-hand side. There could be a peak there, but not the peak of this 3. So we're going to go ahead and move this E over to this 2. And then we'll move over here. Our midpoint is now here. We're using a floor. That is why we moved the E here. Then we see a 2 as well. Then we compare it to this 3. This 3 is greater than this 2, so what we're going to do is not collapse that. We're going to move our s to m plus 1, which would be this 3. Our now new midpointer based on a math floor is this 3. Compare this 3 to this 2. N gets moved over. And now start is no longer less than end. And guess what? We have found our peak. So that is the logic we're going to be implementing. It's very similar to, it is a binary search. This is a different implementation of a binary search than what most people would actually use it for, which is a sorted array. So let's go ahead and jump into this. So we're going to do our usual binary search variables. We're going to have our start and we're going to have our end, and our end will be our nums.length. If I can spell, -1. And then we're going to do our classic while loop. So while our start is less than our end, so if they cross over or they're the same, we know that we have found our peak. So while our start is less than our end, we're going to say let our midpoint, you could say const mid is equal to our math.floor. If you use ceiling, you would change the logic up a little bit, and we could talk about that in a second. Start plus end, we're getting our average divided by 2. And then if, classic if statement, if our nums at mid is greater than our nums at mid plus 1. So this logic here is we're using it to check the element to the right of the mid If it is greater than, that means the hill is going from right to left in an upward slope. If it is, I guess, less than that, then we'd be going from left to right in an upward slope, and we would move that way. But because in this case our mid is greater than the right, that means we need to move to the left because that is where our peak will be. So what we'll say is our end is now equal to our mid. If we did a math.ceiling, it would be mid minus 1, and this would be a little bit different. And then our else statement would be else our start is equal to mid plus 1. And we do this plus 1 because of this floor that we're using. If it's a ceiling, we do not do plus 1. We would do minus 1 here. Yeah, and then eventually they'll cross over and we'll break out. And then at that point, you can return our start. You could also return our end. It doesn't matter. We're going to go ahead and just return start. Let's run it. Let's pass. Boom. There we go. I'll show you if we return an end as well. And boom, it's the same answer. It doesn't matter. By the time we get to our peak, start and end will be the same value. So pretty good. Let's go ahead and submit it. Let's see what our runtime is. Hey, we're better than 67.18% of users and 59.54. We're slightly above average in memory and a little bit higher in runtime. So pretty good solve time. So this would be, of course, as it says, O log n time. And we're doing that because of our binary search. And a binary search, all it does is it divides by 2 constantly until you get to 1. So we're reducing every time. And boom. Yeah, pretty fun stuff. And then, yeah, space would be O of 1, O of 1, O of 1. So just constant space and a log of n time complexity. Great. If you have any questions, post them below. I'm going to be trying something new. A user suggested I kind of use maybe a pen and paper. I'm going to be probably trying to use, what would that be? I guess Excalidraw next time and just explain the logic that way. So be on the lookout for my next video where we kind of dive a little bit deeper into the thought process about approaching a question like this. If you have any questions, put them below. I'll help you out a little bit. Like and subscribe, etc. Helps out the channel, gives me motivation to keep going. And yeah, hope you guys have a great day. Bye.